Okay, so we are back with number 10, difference of squares. And difference of squares kind of seems like a magic trick unless someone takes the time to explain why it works. And so I'm going to take the time to explain why it works with number 1, and then we'll just accept that fact after that with the following problems. And so you'll see one thing that's different about number 1 is we only have 2 terms in comparison to we would normally have 3 terms. So if we were to think about this like we have in the past, we have an A term and we have a C term. We are missing the B term. There's no just straight up X. And so I'm going to rewrite this with a B term in there. So x squared plus 0 x's, that's our B term, minus 49. And then we're going to treat this exactly how we have with previous things that we needed to factor, and we're going to use the AC method. And so here's my A term, here's my C term. Multiply my A by my C, and I get 1 times 49, which is 49. I find all the factors of 49. It is 1 and 49, and 7 times 7. So what we see, those are our only options. We need a combination of numbers that would make, when we add or subtract them, would make our middle term, which is 0. And so 7 minus 7 makes 0, and so that will work out well for us. So what we will do is say x squared plus 7x minus 7x minus 49, and that's going to work for us. So doing the AAC method again, we separate this down the middle, and we get, on the left I could factor out an x. I would be left with x plus 7. On the right I could factor out a negative 7. That's going to make it look the same, an x plus 7. And then, as we have in the past, we can take both of these because they are an x plus 7 and factor those out. And we would have x plus 7 times what's left is x minus 7. Now the important thing to see here is that we ended up with 2 things that look almost identical, the red one and the yellow one. Except the only difference is that one has a plus sign in the middle and the other one has a negative sign in the middle. And so this whole difference of squares thing is referencing this idea that if we have something like this that we started with, we see that x squared is a perfect square. We see 49 is also a perfect square, and they are separated by a minus sign. That's where the word difference comes from. So we have a difference of 2 perfect squares. The shortcut trick or the magic trick for this is to say, oh look, I'm going to do this in black. I have x squared minus 49. That's a perfect square. That's a perfect square. And that's a minus sign. If that is true, I have a perfect square separated by a minus sign. All we need to do is I like to call these my Mickey Mouse ears, put a plus sign on one, put a minus sign on the other. Square root of x squared is x, and square root of 49 is 7. And that's all we need to do is just fill that in. The work I did in blue on the left is why it works. The shortcut is what I did in black on the right. And so we're just going to go with the shortcut from here forward. Again, we'll make sure that we have 2 perfect squares separated by a minus sign to be able to use this method. And I'm going to pause there so you can maybe rewind and watch it again, or pause, whatever you need to do. Then I'm going to move on. So again, we're going to go with the shortcut here, but I could rewrite this as negative 9w squared plus 0w plus 49 and use the AC method to do that, just like we have in the past. I'm going to choose not to do that. I'm going to use the little, you can call it a magic trick if you want, but we're going to notice that that is a perfect square. Square root of 49 is 7. That's a minus sign. and that's a perfect square. The square root of 9w squared would be 3w. So what we're going to have is 49 minus 9w squared. And we could rewrite that flipped around with the negative 9w squared in the front. It doesn't matter. We just jump straight to the end. Mickey Mouse here is one of these has a plus sign, one of these has a minus sign. Square root of 49 is 7. Square root of 9w squared is 3w. And now if you were to multiply this out, you would end up with 49 in the front. Plus 21w minus 21w would make nothing. And then we end up with negative 9w squared on the end. So I'll go ahead and run that through just to show. So again, I like to use my box method. So this is just kind of checking my work. 7, 3w, plus 3w, 7 minus 3w. I would have 49, 21w, negative 21w, and negative 9w squared. So that would turn into 49 plus 21w minus 21w minus 9w squared. These two here in the middle would cancel each other out because they are opposites of each other. And we would be left with 49 minus 9w squared, which is what we started with. And so, again, the difference of squares is really a pretty simple little trick that really speeds things up if you notice that you have two perfect squares separated by a minus sign. I'm going to go up here and box my answer in really quick. And then back down here. That's kind of why it works. And again, for these next ones, we're just going to jump straight to the quick method. Not go through all the steps to show why it works and such. But I hope these two examples make sense and give you sort of some context for why what we're doing works. Let's take a look at the next one. And so for the next one, I do notice again that I have a perfect square. Separated by a minus sign, and then another perfect square. Now remember, I could put a middle term in here or a b term. We're not going to do that. We're just going to go straight from what we've got to the answer because we can. We know that perfect squares have a unique property about them that allows us to do that. So we jump straight to our Mickey Mouse ears. One of these has a plus sign, one of these has a minus sign. Square root of 49v to the power of 2 is 7v. And I hate that they use v's and u's. They almost look the same and it gets confusing. So 7v on each side, plus 3u, and minus 3u. So again, the square root of 9 is 3. Square root of u squared is u. So bing, bang, boom. That's it for number 3. Number 4 is a bit wacky because 50 is not a perfect square, and neither is 8. But we can do something about that. Because we can notice that, hey, I could divide both sides by 2. Or I could divide the whole thing by 2. And if I factor out a 2, I get 25y to the 4th. And I could actually take out a y to the power of 2 also. I didn't even notice that. So let's see what happens if we do that. If we take out a 2y to the power of 2. Both those terms have a 2y to the power of 2 in them. So if we divide by that, we get 25y to the power of 2. 8 divided by 2 makes 4, and the y to the power of 2 will drop out because we've divided by it. And so now what we need to focus on is factoring this piece here in the middle. So I see that's a perfect square. That's a minus sign, and that's a perfect square. So we need to keep that 2y to the power of 2 on the outside there. Then Mickey Mouse ears. One of these is going to be a plus sign, one of these is going to be a minus sign. 5y is the square root of 25y squared. And then the square root of 4 is going to be 2. And so again, because it's a difference of squares, we have that minus sign between two perfect squares. We can just jump straight to that last piece there. And we know that that is our solution. Okay, I need to box in my answer up here. I'll leave that there for a moment and onto the last. Okay, so we have a similar situation as we did on the last one where 32 is not a perfect square and neither is 2. So we're going to look for factors that we could take out straight out of the gate. And I see that they all share a 2. And they both have a y squared. So I can factor out a 2y squared, which leaves me with 16 minus w to the power of 4. Now, as we've done in the past, I see that that's a perfect square. That's a minus sign. And that's a perfect square. So we can jump straight to the Mickey Mouse ears. One of these has a plus, one of these has a minus, and the square root of 16 is 4. Square root of w to the power of 4 is w to the power of 2. And that's it for number 5. I will say once more, this only works with perfect squares that are separated by a minus sign. So you have to have a binomial, which is 2 terms. They both have to be perfect squares, and they have to be separated by a minus sign. If you've got 3 terms, you're automatically going to factoring by grouping, which we covered in the last lesson. At any rate, I hope that was helpful, and I hope you have an awesome day.